Welcome once again to this class. Today, we are going to talk on the topic called normal distribution. It's under probability or specific objective. At the end, you have to know the definition of normal distribution, basic fact about the normal distribution, the calculation of normal distribution. Definition of normal distribution. The normal distribution is an example of what? Continuous random variable. Any problem given under normal distribution must be in the standard form. That is to say, z, the standard form z equals x minus nu all over this. The symbol you are seeing, where x is just maybe the score, maybe a score, nu equals mean. Why this represent standard deviation, standard deviation. Basic fact we need to know about the normal distribution are as follow. One, it has a bell shape. It has a bell shape. Look at what I mean by bell shape. Origin. This part is half, that's 0.5. Here is also 0.5. Positive side, this is the negative part. So it has a bell shape. That's one basic thing you need to know about the normal distribution. The second one, the curve is symmetrical about a vertical axis through the mean, about a vertical axis, okay? Through the mean, meaning here is the mean. Now, the symbol you are seeing. Number three, the curve approaches the horizontal axis asymptotically as we proceed in either direction, away from the what? The mean. That's another fact you should know about it. Now, the total area under the curve and above the horizontal are equal to what? 1. That's the total area. Can you see this is 0.5? I say 0.5 plus another 0.5 equals what? 1. So the total area under the curve and above the horizontal axis is equal to what? See, horizontal axis above, when you add them, equals what? 1. Finally, the mode occurs at x equals what? Mean. That's where the scores of a given set of numbers is equal to the mean. You say that's where the mode occurs. So if you were asked a question, what is the mode of whatever? So try to check where the variable or the scores given is equal to the what? The mean of the given question. So at that point, the mode is seen, and this point where the curve is maximum, that's where the curve has its maximum solution. Now, let us venture into question. Calculation of normal distribution. Now, the height in meters of some men are assumed to be what? normally distributed with mean of 1.73 and standard deviation of 0.1. Now, find the proportion of men whose heights are what? Less than 7. In inequality, you know that less than is the symbol this. Less than or equal to is this. Now we are interested to know the proportion of men whose heights are less than 1.77. Don't be in haste. The standard score z equals who? X minus who? Mean all over who? Standard deviation. Here we don't have z. Z will give us that's probability of x less than 1.77. Then we still have this formula to be equal to that's probability of x less than equals 1.77 is also equal to the probability of whatever z will give to us, maybe z less than equals, there must be a solution. So that one, you are going to trace it from the what? The table, normal distribution table. Now, let's solve this question. X here is what? 1.77. Why the mean is 1.73. Standard deviation is who? So 1.77 minus mean. What is our mean? 1.73. All over standard deviation. Before we proceed, look at this sketch. If your solution is within this way, maybe you have a value here. You know, here is 0. If solution is equal to 2, you then say that's the part not included, that's 0.5, the minus solution. But if this is within like this, I have, let's say, a very narrow value above 0, 0.4, maybe just within. Then the area not included, that's 0.5 plus who? Solution. Just take notes. The next one you need to know, when you have this, if it's within this way and this way, the middle, the solution is in between like this, and like this. Meaning we have exhausted both the negative part and the positive part. Meaning whatever that is our solution, maybe let's say 0.3, from normal distribution table, when we get the value, this value plus this value equals who? Final solution. We are not using 0.5 minus or 0.5 plus. Take note. Now let us finish this part. 1.77 minus 1.73, this is 4, 0.04. Then divided by 0.1. This equals okay, let's convert this to 4 all over 100 divided by 1 all over 10. This will give us 4 all over 100 times 10 all over 1, 0, 0. This is 4 over 10. This is 2 over 5. This is 0.4. Good. So the solution is what? 0.4. But this is not the final answer. We are going to trace from table. Now using table, let me draw first. I've given you these as samples. Just watch it once again. If you need to draw it and have it as a reference image when you are solving. So that's okay. Now I have to represent (0.4) is greater than who? 0. So downwards, this is our central part, which is the 0. Let's say here is 0.4. So since this is greater, you can see every other here is included. So to get our final solution, this part 0.5, this which is half, plus the solution from table, that is plus value of 0.4 from table. So to present this now, we now have that the probability of PR of X less than 1.77 equals PR of Z less than 0.4, because Z equals what? 0.4. Now this is a pre-solution. Then this is the one that will lead to the final solution. So PR of Z less than 0.4 from table will now give us 0.1554, just like the way you read your log reading. If you open a normal distribution chart, go to normal distribution, you check, that's 0 under who? 4. It will give you a value. The value is what? 0.1554. Recall, we'll have this part to be completed because we covered it. So this will now give us 0.5 plus who? 0.1554. So I want to finalize for the first question. Zero 0.5 plus 0.1554. Solution is what? 0.6554. So this is the solution to this question. Like I told you, this is still probability, just that it's a special name, normal distribution. And if you can remember what I told you about probability, your answer cannot be greater than 1. So what are you saying? 0.6554, not greater than 1. So it's correct. So the next one, we are going to have the value, let's write this first. Okay, I think we're good to go. Between 1.6 and 1.75, 1.67 and 1. Okay, z equals x minus nu all over standard deviation. First z, I can call it z1, is my choice against the first value, 1.67 minus mean nu all over 0.1. I will have 1.77, 1.67. This is 0, 1, 0.1. But remember, a smaller number is subtracting. So it will give us what? Minus 0. Or let's say 1.67, 1.77. Okay. Is 0. 16 minus 7 will give us, okay, minus 0.10. Because a smaller number subtracted is minus 0.10. So this will now divide by 0.1. You know, this 0.10 is the same thing as 0.1. I will divide this against itself. All over 0.1 is still giving us minus 1.0. So this is the first z. Let's go over to second z. The second value of z, 1.7. Okay, I think there is something here we skipped. This 1.73. (1.67) minus 1.73, minus 0.06 divided by 0.1 minus 0.6. First z, the second z, we have z equals mean. What's the mean? 1.75 minus, that's the score, 1.75 minus mean, 1.73, all over 0.1. So 1.75 minus 1.73 all over 0.1 will give us second z value is 0.2. So what are we drawing? We are drawing the best shape we know to exist like this. Remember, this is the center, the 0, 0.1, 0.2, 0.3, whatever, maybe 0.6 can be here, while 0.1, 0.2 can be here. Meaning, take this line up, take this one up, you shade it, because they are in between each other. That's it. Between. Now they are between. Whatever value we have for this from table and whatever value we have for this from table, we'll add it to each other. Now let's check the value of minus 0.6 PR of Z equals minus 0.6. PR of Z when equal to minus 0.6, and the second one PR 0.2. From table now, minus 0.6 just check 0 under 6, you will have a value under your from the table of normal distribution, and that value here is 0.2258. I'll write 0.2258, then plus. Remember I told you we don't need 0.5 plus or 0.5 minus because we have two values. So it's just they are in between, they're between each other. So we are adding the value we have for them, 0.0795. 0.0795. So the value for 0 under 2 is what? 0.0795. Then we'll add together 58, 0.0795. This is 13, carry 1, 14, 15, 9, 10, carry 1, 3, 0.3053. Therefore, the probability of Z, that is PR of 1.67 less than S less than equal to 1.75 equals PR of Z, PR of minus 0.6 less than equals Z less than equals to 0.2 equals what? 0.3053. Final answer to that question. So that is the probability or the proportion of men whose heights are less than 1.77 in the first solution and whose eye lies between 1.67 and 1.75, which is what? 0.3053. Let's take a look at another question. A case where the standard deviation, where the standard deviation is, let's say the standard deviation equals 0.3. Let me not use 0.5. Okay. Where X is between 1.85 and 1.93. Okay, let me just set up this for you, but I want you to get the normal distribution table. If you can see it, just Google it. You see the normal distribution table online. Then open it up and trace the values of whatever you're going to get here now. But let me just set it up for you. So look at the first Z. I will say PR of 1.85, which is between this, that's X, then less than who? Less than or equal to 1.93. Now, for Z score, as a PR of Z less than whoever we're going to get for the first value here. So let's keep it first. Then, first Z equals 1.85 minus the mean 1.73 all over. We have changed the standard deviation, remember. So Z for here is going to be 1.85 85 minus 1.73 equals 0.119. 0.119 all over 0.3. Z1, according to your description, equals 0.3999, which approximately equals 0.4. Now, according to your description, Z2 equals 1.93 minus 1.73 divided by 0.3. This will give us 1.93 minus 1.73 equals this 0.19999 all over 0.3. Okay, 0.666, that is 0.67. So in this case, this one how enter with two decimal places. Look at what you check. It says 0 under 6. Then there is going to be a difference of 7 that's in front of it. So you trace it and add to that one. But this one is just straightforward. So how do you draw your table, your diagram? That bell-shaped diagram is going to look like this. Remember, you have double positive. And remember, left-hand side is just negative. You are not coming there. This is the smaller one is 0.4. Let's assume something somewhere here. Okay. Then the other one approaching this side 0.6. Meaning you are going like this. Can you see it? Okay. You just see here. What do you notice? We have this side, though this is just between. When you get the value for this, you get the value for this, you now add the two together. That will now give you the final solution. Once again, I want to tell you, remain blessed, and don't forget to subscribe to our channel for more revelation. In the next probability we are going to handle, we shall be talking about the Poisson distribution, because most of you are bothered about Poisson distribution. Thank you once again for being part of us.